What's up, everyone? Mr. Bainey here. This lesson is 1.1 rational and irrational numbers. The essential question here is, how do you rewrite rational numbers and decimals, take square roots and cube roots, and approximate irrational numbers? And the standard up at the top right is 8ns.1. Know that numbers that are not rational are called irrational. Understand informally that every number has a decimal expansion. For rational numbers, show that the decimal expansion repeats eventually, and convert a decimal expansion which repeats eventually into a rational number. So you can see this lesson is quite heavy. There's a lot to do here. So let's go right into it. The first part, expressing rational numbers as decimals. That's rational. We'll talk more about that probably in lesson 2. But I would say the easiest way to explain this is that rational numbers can be written as fractions. So think of rational as ratio, and ratios are fractions. So we're going to change fractions to decimals. And when we change it to a decimal, there's two things that can happen. We can end up with a terminating decimal, or we can end up with a repeating decimal. Okay, so let's try out some examples. It's a good idea to read these ones below here, example A and B, if you wanted to get a little bit more. So let's go ahead and do the your turn here, 1, 2, and 3. Remember that the fraction bar in between the numerator and denominator means division. So we're going to be dividing 5 by 11, and that means we'll write it something like this: 5 divided by 11. Okay, that 5's inside there when we're doing our long division. Since 11 goes into 5 0 times, let's add some zeros after the decimal and bring this decimal up. Okay, 11 goes into 50 4 times. 4 times 11 is 44. Bring down 6. Then 11 goes into 60 5 times to get 55. And I get a remainder of 5. Bring down to 0. 11 goes into 50 4 times. And that gets me, sorry, this is a little hard to read because I'm writing over the next title here. 44, subtract, you get 6. And then it's going to repeat. So you should be getting, whenever you realize it's going to start repeating, you can stop, but try not to stop too early. So it is going to be repeating 0.4545454545. So the way we write that is 5/11ths will equal 0.45 with the bar over both of them, because both repeat. Okay, number 2. 1 divided by 8 looks like this. 1 divided by 8. 8 goes in to 1 0 times, so let's add some zeros after the decimal point here and bring up the decimal. 8 goes into 10 1 time. 8 goes into 20 2 times. And 8 goes into 40 exactly 5 times without any more remainder. So 1/8 is equal to 0.125. Number 3, 2 1/3 is going to, hopefully you know that in the ones place there's a 2. So when I write my decimal, I can automatically write 2 point and then figure out what that something is. So 1/3 means 1 divided by 3. And 1/3 is something that I would like for you to memorize because it's one that's used pretty often. 3 goes into 1 0 times, but it goes into 10. Let me bring up this decimal. Goes into 10 3 times, which is 9. And then bring down the remainder 1, bring down to 0. 3 goes into 10 3 times, right? 9. And then at this point, hopefully you notice it's going to be repeating. So our answer here, our decimal equivalent of 2 1/3, is 2.3 repeating. Okay, the next example is writing from a decimal to a fraction. So now we're going backwards from what we just did. And in order for us to do this, we need to know our place values. Part A, example A, shows converting a terminating decimal to a fraction. And then example B shows going from a repeating decimal to a fraction. So you can certainly go through this process that you see in example B, but I'm not going to show you that process. I'm going to show you a slightly different one that you may not have seen before. And I could definitely show you why it works, and it's pretty much based on this. Okay, it's you can think of it almost like a shortcut. So let's go on to the next page. So directly to the your turns. I'm not going to be writing some of this down. We're going to be taking some different notes in class. So if you miss class, be sure to get some notes from me if you're still needing some more. Number 4, the very last number. Think about what place value that is. First of all, the 1 is the tenths place, meaning that the 2 is in the hundredths place. So if that's the hundredths place, then it's going to be 12, right? Because that's what that number is, 12, over 100. Okay, so the denominator is always going to match the place value of the last number. And then 12 over 100, we can reduce that. I know that 2 goes into both, but 4 is bigger, and it does also go into both. And that comes out to 3 over 25, which is reduced all the way. So 0.12 or 0.12 is changed as a fraction to 3/25. Okay, and they're both exactly the same value. Number 5, so now we have a repeating decimal, 0.57 repeating, which means it's 0.5757575757, and so on. So this is going to be very similar. Think about the place value of the last number. It's hundredths. So I'm going to be writing 57 over 100. And because it's repeating, the shortcut is to subtract 1 from your denominator. So that means it is actually 57 over 99. Okay, and this will always work as long as you select that correct denominator to start with, right? Remember, it's based on the place value. So from here, we can go ahead and reduce it. And I didn't mention this, but right above it does say write it in simplest form. That's important. That means you need to reduce it. So when we divide both by 3, we're going to end up getting 19 on the top. Okay, that's 57 divided by 3. And then 99 divided by 3 is 33. And the last one, you can go ahead and try the last one. Go and pause the video and try it. I'll just go ahead and put out the answer there. It is 1. Actually, I'm going to start at the bottom. It is 1 and 4 tenths. And 1 and 4 tenths reduces to 1 and 2 fifths. Okay. The next set of problems involves finding square roots and cube roots. So we got a lot of vocab here. The square root has to do with perfect squares. So in our class notes, we do have a list of the perfect squares. They're really, really good to try to memorize as much as possible. So perfect squares, I might ask you, do you know your perfect squares? And that means take all of the numbers that we count with and square them, right? So what's 1 squared? That's 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And if I continue that pattern, 6 squared, 7 squared, 8 squared, 9 squared is 81. 10 squared, 11 squared, and 12 squared. I highly recommend you memorize up to 12 squared. That's going to help you a lot, and you don't have to You don't have to, you know, do as much scratch work, or you don't have to, you know, just think as much about these if you memorize those ones. So those are our perfect squares. Square root is like going backwards, or we call it the inverse operation. So if I say, well, what's the square root of 36? That's 6, because we got this from 6 squared. So the square root of this is 6. And it tells you right up here in the description. Okay. The cube root looks like this. So I'm pointing out here in the paragraph. It looks like this little square root symbol with a 3 just right outside of it. The square root symbol, I forgot to mention, was right up here near the top. Okay, perfect cube is just like perfect square, except we're cubing everything. That means multiplying it by itself 3 times. So 1 cubed means 1 times 1 times 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is going to come out to 27, and 4 cubed is going to come out to 64, and 5 cubed, 5 times 5 times 5, is 125, and then I don't really remember much after that because these numbers get so big. So if you can memorize at least up to that much, I think that's going to be enough. So what are we going to be doing with this? If you look at the examples below, we are going to be solving some equations. So if you take a look at A and B, that'll give you a sense of what our work is going to look like. And let's try some your terms. And there's also examples C and D. So there's a lot going on here as well. A and B have to do with perfect squares, and then C and D have to do with perfect cubes. So keep that in mind. Look over those to see if they make sense. But let's go ahead and try the your turns. If you feel like you know how to do it, try it out before you see the answer. Number 7, x squared equals 196. So what you're going to do here is you take the square root of both. And really what you're asking here is what number can I put here so that when I square it, I get 196. Okay, and there's actually 2 answers here. So x is going to be equal to this. So this symbol, I'll describe it in just a minute. But the square root of 196 is 16, because 16 times 16 is 196. So now this symbol that I wrote here, this is a plus sign and a minus sign, that you can think of it as a positive and a negative. So my 2 answers are positive 16 and negative 16. So this is just a shorter way of writing it. Okay, I'll write it a slightly different way when we do number 8. But think about this. Positive 16 squared is 196. So that means 16 times 16. But also negative 16 squared. So if I think about this also, negative 16 times negative 16 is also 196. So multiplying it by itself twice is going to get you a positive answer no matter what. Number 8. Same thing here. I'm going to take the square root, right? And when I do that, I'm going to get 2 answers for a square root, right, for this equation actually. So x is going to equal, so this is a little bit trickier, but not so much. When we have a fraction like this, you can do this separately, meaning what's the square root of 9 and what's the square root of 256. And so we end up getting 3 on the top, right? Square root of 9 is 3. And the square root of 256, that one is that one 16? Yeah, I think I have the other one incorrect. I need to go back to the other problem. I apologize. And this one actually should be, 14. So plus or minus 14, or sorry, positive 14 or negative 14. So for number 8, going back to that, 3 over 16, I just misremembered my perfect squares. So you can see I kind of forget some of those sometimes that higher than 12 squared. So our two answers for number 8, I can write it this way. I can write 3/16 or negative 3/16. So I could write the two different answers as opposed to how I did it for number 7, either way. Number 9, so we have x cubed, which means I need to do a cube root this time. So notice how I wrote that in blue. And a cube root of 512. So x is going to equal whatever the cube root of 512 is. And I don't remember it off the top of my head. You're going to have to figure out, or maybe I can try to look it up really quick. What number times itself 3 times is going to be 112. And while I'm trying to crank out that answer, let's do number 10. Let's do the same thing here. We're going to take the cube root of this, the cube root of this, and I'm not going to really talk about it a whole lot, but think about why we're only getting one answer here instead of 2. Right? Number 7 and 8, we have 2 answers, but here just 1. So for number 10, we're going to get 4, right? The cube root of 64 is 4. And the cube root of 343 is, I need to also figure out that one, is 7. So the answer to number 10 is x equals 4 over 7. The answer to number 9 is actually 8, because 8 times 8 times 8 will give you 512. When the numbers are big like this, using a calculator is going to be okay for me. When it comes to a quiz or a test, if I don't allow you to use a calculator, I will be keeping the numbers small enough, just so that you don't have to, deal with those big numbers and have to do a lot of side work. And the very last thing that you'll want to worry about in this lesson is to estimate irrational numbers. And the irrational numbers that we'll be talking about here are square roots. So when they're not perfect squares, so numbers like 7, right? 7 is not a perfect square. 9 is a perfect square. 16 is a perfect square. And 25 is a perfect square. And so on. There's a ton of them. But there's a lot of numbers that aren't perfect squares. So when we do something like estimate the value of the square root of 2, you follow these steps here. Okay, so I'm going to fill in some of the blanks for you. You can review this on your own on how exactly this works. But we're going to find 2 consecutive perfect squares that 2 is between. So if you remember, my perfect squares are 1, 4, 9, 16, 25, 36, 49, and so on and so on. But 2 is in between the perfect squares 1 and 4. Right? 2 is a pretty small number. So we're going to take the square root of each of those numbers. So the square root of 1, the square root of 2, and the square root of 4. Well, we know the square root of 1 is 1, and the square root of 4 is 2. So this means that my square root of 2, right there that I've circled, is in between the number 1 and 2. So it's going to be like 1 point something. Okay, this is, I'm actually going to stop right here because you don't need to, I'm not going to worry about you knowing much more than that. I would like you to figure out which one is it closer to. Is it closer to 1 or 2? And try to make a guess of what the decimal could be, right? If you were to put this thing into a calculator, what's the decimal? So you can guess, because the square root of 2 is closer to, I'm going to mark it in red here on the right side. It's closer to 1, right? It's not that close to 4 over here to that side. So it's closer to 1, which means that it's going to be something like, I don't know, I'm going to write the approximate sign here. So I'm going to guess something like 1.3 or 1.4 even. So something like that. But I want you to try to make an educated guess just based on how big or small a number is. And then make a guess of what the decimal number is. Okay? Thank you so much for watching. Let me know if you have any questions. Come in and see me. Have a good day.